Good afternoon, ladies and gentlemen. This is the scoring guidelines for 4-7 properties of water free response that you guys did. I'm going to go through how it was scored and talk a little bit about the questions. So the first question was, describe why hydrogen bonds form between water molecules. This one is a describe question. So describe means I need 2 or 3 sentences. You're going to see this on your test. So when you guys see describe, I'm looking for an actual description. This statement said hydrogen bonds form between water molecules because hydrogen atoms in water are attracted to oxygen. To get the full points, it did not indicate that there's a slightly negative charge on the oxygen and a positive on the hydrogen. That's basically what I was looking for, is that attraction between 2 molecules. Another thing is you couldn't just say that it was between the hydrogen and oxygen, positive and negative, and not say that it's 2 different molecules. Okay, all right, so let's look at the next one. This person earned a full point. Water is a polar molecule. It has opposite charges, slightly positive hydrogen bonds. It's just slightly negative oxygen. Hydrogen bonds form between the hydrogen of one molecule and the oxygen of another. Excellent response. 2 different molecules. Talked about which one was positive and which one was negative. Good job on that one. All right, part C. Or sorry, part B. This person did not earn the point. Let's see why. Explain. Okay, explain again. That means a couple of sentences. Explain or describe. It means give some meat to your answer. All right, explain why the arrangement of water molecules is different in ice and in water. Well, first of all, in water, the molecules are moving a lot quicker. Okay, so those hydrogen bonds can break and form a lot more easily. In solids, the water molecules are vibrating in place and not really moving, creating that crystal lattice structure, kind of what we're looking for in our answer. All right, in water, the molecules move fluently, meaning that they do not have a set point, while in ice, the molecules make a solid, so they have to stay in place. We're looking for energy levels in the molecules, so either moving faster or higher energy in the liquid, lower energy, moving slower in the solid, hence staying in place. So this person did not get a point. The response does not indicate that as water cools, the water molecules slow down or lose energy, and the hydrogen bonds between them become more stable. Okay, so the slower it's moving, the more stable those bonds are. The response does not indicate that as ice forms, the hydrogen bonds cause the water molecules to space out in a crystal form. On the contrary, the response does not indicate that since the water molecules are at a greater temperature, the molecules are moving more rapidly, breaking hydrogen bonds. Okay, all right, let's go to the next one. Okay, this person earned a point. The arrangement is different because in the ice, the water molecules are low in energy, causing their hydrogen bonds to extend in a pattern rather than in water. Molecules have a higher energy and the bonds can form loosely and rapidly, making it move. So this one was a point. Okay, all right, the next question, you did not have to do C. It was drawing the arrows. You did not have to do this one. All right, D. The arrangement of water molecules in ice causes the ice to float. Explain. That means more than one sentence, please. Explain how ice floating on the surface of water affects the water in a way that is beneficial to the organisms in it. So this was explain how ice floating on the surface of a body of water affects the water in a way. So how is that affecting it? If the ice were to sink, organisms would either freeze or suffocate. So the ice floats, it allows organisms to survive. That's true, but it's not telling me how water does this. How does water affect it so that this happens? The response did not indicate that the floating ice will reduce heat loss from the water below the ice. Response does not indicate that the results in the warmer water is not likely to freeze on the bottom of the body of water. Okay, looking for that word insulator, basically. Okay. In winter, when the surface temperatures are low enough for water to freeze, floating ice forms a layer of isolation on top of the water. I think they meant to say insulation there. It insulates the water below, which allows life to survive. And that key word there, insulates, is what we were looking for, allowing it not to freeze on the bottom. All right. Next question. This one was a tough one. This was a 3-part question, and it was a little bit tricky to score. Identify 3 macromolecules that are components of the plasma membrane. So they had to be in the membrane. in a eukaryotic cell and discuss the structure and function of each. 1 point for the name of the macromolecule and an explanation of its structure. So if you just said lipid and didn't give me a structure with it, just a function, that whole word lipid doesn't get the point. And then 1 point for each macromolecule plus function. Okay, so you get 1 point for macromolecule and structure, and then 1 point for its function. So let's look at some answers. Okay, this person earned a point. Phospholipids, they allow substances through the membrane and keep others out, and it separates the inside from the outside of the cell. This was an identify and a discuss. So identify would have been the phospholipid, and they told me what its function was. That tied it to a complete point. So it could have been phospholipid with structure or phospholipid with function, and it could have gotten a point, but they missed the structure part here. So this was a 1 point answer. So the idea is you want to give me the macromolecule, you want to give me its structure, and then you want to give me its function. Okay, so it says identify and then discuss the structure and function. All right, question. Here's another one. Phospholipids, which structure consists of a polar head and a nonpolar tail. Very good. That's a point. Its function is selective permeability. That's a 2nd point. Very good. Cholesterol, which has the structure that has a lipid bilayer. That's not correct. The function is to keep the membrane stable. So they got a point on function there. That was their point number 3. Proteins, which have a function, consists of amino acids. They're saying that their function is consisting of amino acid. It doesn't make any sense. The function is transport and being a catalyst. Okay, so that was kind of mishmash there, where it wasn't clear. There's statements here, but they were not clearly tied. Okay, so that was a 3-point response. All right, this person earned the full 6. In eukaryotic cells, the most obvious macromolecule found in the plasma membrane are phospholipids. These lipids contain 2 fatty acid tails and a phosphate head. There's a point. The phosphate head forms a hydrophilic outer layer on the surface of the membrane. The lipid tails form the hydrophobic interior of the membrane. Because the hydrophobic interior, some molecules that are polar will need assistance to pass through the membrane. Okay, so there's 2 points there for structure and function. Proteins are scattered throughout the membrane, which go through the surface of the membrane to the cell. Okay, so that's a structure point. Proteins allow large polar molecules to enter, 2nd point. Okay, so that's 4 points so far they've gotten. All right, lastly, carbohydrates that exist on the surface of membranes and can exist as glycoproteins or glycolipids. That's a structure point. Okay? These carbohydrates act as markers and enable cell communication. That is a function point. So for each of these, you needed the name, the structure, and the function for all 3. There was no points for just giving the name without structure or function on it. All right, directions. This one was an older question, so the stuff isn't bolded here or separated for you. It says, describe the smaller units, their assembly into larger structures, and one major function of these larger organized structures. There's 4 points hidden in here. Okay. All right, so let's look at how it was broken down. If you look over here, the scoring guidelines say 1 point for structure. It's made of amino acids and a polypeptide. Organization, you could have talked about any way that the proteins put together, 2 separate components there. And then 1 benefit, like what do they do? What's a function or a benefit of them? Okay. All right. And then we have the scoring breakdown with some things. Down here, be careful. It's not, you cannot simply say it catalyzes a reaction. You have to describe. So if we go back up here, it says describe, not state. Okay, so describe what that function does and talk about how it lowers the activation energy. All right, so this is the first response. Enzymes are made up of amino acids. That's a point, okay, because that's a structure, the structure point. These amino acids are put together to form long polypeptide chain. That's also a structure point. That's within that same point. And then one major function of the enzyme would be lower activation energy. Now, the reason they didn't get that is because this is a describe question. So you are not describing if you're stating what's in the scoring guideline. That's an identify or a state. They're asking for you for a description. So one function would be to lower the activation energy and then go into like why or how, or give me some explanation there. So this person earned the first structure point. All right, this one got the full 4. Enzymes are usually proteins or polypeptide chains. Polypeptide chains are made of amino acids bond together by dehydration synthesis to create a primary structure. That is great. This is a structure, and then the first part of the makeup, the makeup of the protein, second part of the scoring piece. The polypeptide's primary structure folds to create its secondary structure, then it's R group's interactive form tertiary. The final result is enzyme with an active site where molecules combine to. Okay, that's the meat of what they're saying. Enzymes act as catalysts for chemical reactions, allowing them to occur with less energy. So less energy is required. They hit that describe component in here. They're not just stating what's happening, they're describing it. So this was a full 4 points. Okay, guys, I hope you enjoy the rest of your day, and I'm going to move on to the next response. Have a good one.